All right, here's a technique for finding the roots of any quadratic equation, especially ones that don't have a leading coefficient of 1. For instance, let's look at 6x squared minus x minus 2. And we want to find out where the roots of this are, so I'm going to set it equal to 0 because that's where the roots are when this is equal to 0. Now, this is kind of a long procedure, so just follow along and I'll go through it. First thing we're going to do is get rid of this 6 out front here. I want a leading coefficient of 1. So I'm going to divide everything here by 6. So I divide this by 6 and the 6 cancels out and I just have x squared minus, there's an invisible 1 here, so 1/6 x minus 2/6 and then equal to 0 divided by 6, which is still 0. Now, I'm going to leave this as 2/6, even though it could be reduced because it'll come in handy later. Now I'm going to take this term and put it on the other side. I'm going to add 2/6 to both sides. So x squared minus 1/6 x, and I'm going to leave the space for this because I'm going to add something here in a little bit, equals positive 2/6. All right, now what I'm going to do with this expression is I'm going to make it into a perfect square. If you remember, if I take half of this number and square it and put it here, then this is going to be a perfect square. So I'm going to come up here and I'm going to write this. I'm going to take 1/6, then I'm going to take half of it, which is 1/12. I just multiplied 1/6 by 1/2. And what I'm going to do is remember that number. I'm going to use it later. And then I'm going to square it. 1/12 times 1/12 is 1 over 144. I'm going to take that number and add it to both sides. If I add it to both sides, then I still have an equation. And plus 1 over 144. All right, now on this side, I have now changed this into a perfect square because half of this number squared is this one. So I can rewrite this as a perfect square. Now remembering our perfect squares, I'm going to have x minus this half number that I remembered times itself. Which I could rewrite as x minus 1/12 squared. So I'm going to rewrite this side as x minus 1/12 squared. Still equal to the sum of these two numbers. All right, so when I form this addition here, it ends up being equal to 49 over 144. So I can combine that down and make this 49 over 144. Now I have something squared equal to a number, so in order to figure out what this is, I'm going to undo the squared by taking the square root of both sides. So I'll take the square root on this side and the square root on this side. The square root of something squared is just whatever the something is. And it's equal to the square root of this. Now remember that with the square root of a fraction, I could do square root of the numerator over square root of the denominator. Well, 49 and 144 are both perfect square numbers. So this ends up being 7 over 7 over 12. Now, since I took the square root of something squared, what ends up on this side could either be positive or negative, because positive times positive is positive, positive times negative, negative times negative is positive. So we have to say plus or minus, because this could be either positive or negative. Square it, I go back to 49 over 144. So now I can shift over my 1/12 by adding 1/12 to both sides, plus or minus 7/12. So now I have two computations to make, 1/12 plus 7/12 and 1/12 minus 7/12. Well, 1 plus 7 is 8, so could be equal to 8/12, which reduces to 2/3. Or it could be 1 minus 7, which is negative 6/12, which reduces to negative 1/2. And these are my roots, 2/3 and negative 1/2. So I could use those now to form my factors. 3 ends up here with the opposite, up here with the same sign. 2 ends up here with the opposite sign. 2 ends up there. Negative 1 here with the opposite sign. And there are my two factors. Now, just to check my work a little bit, I could multiply these two factors out, see if I get my original quadratic equation. So I've got 3x times 2x is 6x squared. 3x times 1, 3x. Negative 2 times 2, negative 4x. Negative 2 times 1, negative 2. Combining my like terms, I get 6x squared minus x minus 2, which is in fact the same quadratic equation that I started with.